What if the cure for a disease is locked inside someone's DNA, but they're on the other side of the world? Right now, connecting that crucial data with researchers is, well, it's a mess. It's a logistical nightmare of costs, delays, and huge security risks. So today, we're going to dive into a new system called Gene Anchor, and it proposes a pretty radical solution. What if we could turn your genetic data into a secure asset that you control and that can be shared instantly?
So let's just start with this idea. Imagine for a second you contribute your genetic data to, say, a multiple sclerosis study. You're not just doing something amazing for science, you're also getting paid for it. And I mean instantly. Not in a few months, not in a few weeks, but in seconds. That is the really powerful idea we're going to unpack today.
All right, so here's our roadmap. First, we'll take a hard look at the broken system we have right now. Then, we'll explore this new marketplace model GenAnchor is proposing. We're going to get into the nitty-gritty of how it keeps your data secure, how it delivers those instant payouts, and how all of this builds towards something called a digital twin of a patient. And finally, we'll talk about what it really means to treat your own data as an asset.
Okay, first things first, let's diagnose the problem. The pipeline that's supposed to get medical data from patients to researchers is fundamentally broken. I mean, it is clogged with delays, crazy costs, and security risks. It creates all this friction that just slows down the very research that could be saving lives.
And when you put the old way and the new ways side by side, wow, the difference is just staggering. We're talking about taking payment times from as long as 90 days down to nearly instant. Transaction costs, they plummet from over $35 for a single international wire to less than 50 cents. And maybe the most important part, data integrity. It's no longer just stuck on some siloed hospital server somewhere. Instead, it's anchored to the Bitcoin blockchain, a global, unchangeable ledger, which gives us a whole new level of trust.
Just try to think about this from the patient's point of view for a second. You've just shared something incredibly personal and valuable, your genetic code, all to help science. And your reward? You have to wait up to 3 months to get paid? I mean, come on. That's not just an inconvenience. It's a huge reason why people might hesitate to participate in this kind of crucial research in the first place.
So what's the fix? Well, GenAnchor is proposing a totally new model, a genomic data marketplace. The best way to think about it is like a secure digital bridge. It directly connects patients with scientists, and it just gets rid of all the middlemen and borders that are slowing everything down right now.
Really, at its heart, GenAnchor is all about solving what's called the last mile problem in medical research, right? How do you efficiently send a small payment to someone participating in a study anywhere in the world, whether they're in Ohio or a remote village in Kenya, without all the money getting eaten up by fees? That is the fundamental challenge, and that's what this marketplace is built to overcome.
Now, I know what you're thinking. A global marketplace for genetic data sounds great, but it brings up a huge question. How on earth can you do this without compromising the privacy of some of the most sensitive data a person has? Well, the answer lies in this really elegant cryptographic solution that basically proves the data exists without ever revealing the data itself. It's pretty clever.
So, the key concept here is something called a cryptographic hash. The easiest way to think about it is like a unique mathematical fingerprint for your data file. It's totally one of a kind. If you change even a single comma in that original file, this digital fingerprint changes completely. It's basically an unforgeable proof that the original data exists and that it hasn't been messed with.
And here's the secret to how privacy is protected. Only the hash, that digital fingerprint, is ever placed on the public blockchain. All it does is act as a timestamp proof that your data exists and that it's unaltered. Your actual genetic information, that stays completely private, encrypted, and stored safely off the blockchain in a secure vault. This separation of public proof from private data, that is the key to this whole system. And the privacy protections don't stop there. They're layered. The data itself is locked up with AES-256 encryption, which is, a military-grade standard. The key to unlock it is only given to the specific researcher who pays for access. This means zero personal health information ever touches the blockchain, which keeps the system fully compliant with strict privacy rules like HIPAA.
Okay, now we get to the part that completely changes the game for patients, the payout. Forget about waiting for checks in the mail or slow bank transfers. This system is built for almost instant, totally automated rewards. It directly connects the researcher's payment to the patient's wallet in real time.
So here's how it works. It's all automated. It kicks off when a researcher pays using a stable coin, which is basically a digital dollar. That payment triggers a smart contract, which is just a piece of code that automatically executes the deal. The money gets routed globally,
And the very moment the patient receives the payment, the researcher is given access to the data. This whole thing is called an atomic swap because it all happens at once or it doesn't happen at all. There's zero risk for either side.
And the result of all this automation is just incredible. The entire process, from a researcher in one country paying a patient in another, is designed to take less than 60 seconds. Just let that sink in for a moment. A process that used to take up to 90 days is now done in under a minute. Now look, fast payments and secure data are absolute game changers, but they're also laying the foundation for something even bigger, even more profound. This technology makes it possible to create what's called a biomedical digital twin, a comprehensive, dynamic digital model of a patient's health. By using these secure digital pointers, these hashes, researchers can finally start linking different kinds of medical data together safely. Just imagine connecting your genetic code directly to your series of MRI scans over time. Suddenly, you've created this multi-layered, dynamic model of your health that can show us patterns we would never, ever have been able to see before.
And the real power of this digital twin is that it allows for what's called explainable AI. The computer doesn't just spit out a recommendation, it tells you why. A doctor can see that a treatment is being suggested because of a specific genetic marker combined with a visible change in an MRI scan. That kind of transparency is absolutely crucial for building trust and, of course, for making better decisions for patients.
So when you put all of these pieces together, it really points to a fundamental shift in how we think about our own health data. It's all about moving from a model where data is seen as a liability to one where it's treated as an asset. You know, for the longest time, big institutions have treated these massive health data sets as a liability, something to be locked away and protected. And for patients, their data is something they have almost no control over. GenAnchor just flips this entire dynamic on its head. It transforms your data into a verifiable, auditable, and valuable asset that you, the patient, actually control.
And this all brings us to one final, really crucial question. For decades, we've been told to treat our personal data like it's a liability, something to be locked away. But what if the future of both medicine and our own personal empowerment lies not in hiding our data, but in controlling it? This technology really asks us to think about it. Is your data a risk that needs to be managed, or is it a powerful asset just waiting to be unlocked?